Hey there guys, welcome to this video. So in this video, I would be covering a few things, mainly the center around the LlamaIndex new update, which is from 0.9 to 0.10. Loads of changes that were made to the LlamaIndex library. In this video as well, I'll also be talking about very briefly about what an AI stack is and talking about a RAG system. And we're going to be implementing a RAG system using LlamaIndex, OpenAI, and MongoDB as a vector database. As usual, for most of the content I cover in this video, there's going to be a GitHub repository where you can get all the code. There is also an article version of this video that you can read for those who you just want to read and just achieve the same things in this video in about 7 steps. And I also go into some detailed explanation about the steps that I'm taking. All the links to the article and to the repository are going to be in the comment section and in the description below. So let's get started. The term AI stack is being used a lot within the space lately, but generally it's a composition of tools and libraries and software solution that basically achieve the objective of building a generative AI application by the definition today. So that is what an AI stack is. You typically have a programming language, Python, and also TypeScript as well. LlamaIndex does have a TypeScript version, and you have like a LLM orchestrator or a data layer. And in this case, you have LlamaIndex. You can also have LangChain. And typically you have a vector database, but also you're building a software. So a software application. So you need an operational database as well. MongoDB is both a vector database and an operational database. Then you have your model provider, which is in this case is OpenAI. And this is the AI stack. But there is the term AI engineer that is coming out, and really, I think I'm debating is the definition of the role more suited to AI stack engineer, because an AI engineer by the definition today is just using these tools or similar tools to build an application. So are we AI stack engineers or are we AI engineers? Debating that. But let's talk about RAG. So RAG, everyone should know what RAG is, but very quickly, RAG is a system design pattern, leverages information retrieval techniques, embedded models, and generative AI models to provide accurate and relevant responses to user queries, which is done by retrieving semantically relevant data to supplement user queries with additional context, combined that is then combined as input and given to an LLM. So that is what we can describe a RAG as very quickly. And this is a diagram I put together that just shows the flow of a very naive RAG system. You get your data, index, chunk it. This is the data preparation, and you just pass it through an embedding model, which is then stored into a vector database. Then when the user queries, when the user sends a query, we embed that and conduct some retrieval from the vector database. We retrieve and then we supplement it with we retrieve the relevant document and we supplement that with the user query to pass into a model, and then we get the response that we send back to the user. I'm sure this diagram can be improved, but you get the gist. So we can just get straight into the code now. I'm just going to go through this notebook and talk about the steps that I've taken to achieve building this RAG system using the PaLM stack, the PaLM AI stack, which is Python, OpenAI, LlamaIndex, and MongoDB. And so first thing with the new update is there's been some separation of most of the integrations that used to be inside of the whole LlamaIndex library. There's been a separation. So now you have to actually install the vector stores integrations that you would like to use, and also the embedding integrations you would like to use. This adds more simplicity to the core LlamaIndex library. There's an article that details the reasoning and also the migration guide. But this is LlamaIndex currently going to be using the 0.10.5. And we're going to be using other libraries, PyMongo, which allows us to access a MongoDB database and allows us to perform some operations on that database. And then we have datasets, which is a Hugging Face library to access a vast repository of datasets. We're going to be using the movies dataset provided by MongoDB on Hugging Face. Then Pandas is a data processing library that is used to process data frames and analyze data frames. So we're going to install that, which we've done already. And we have the OpenAI key here, removed mine, but you could just insert your OpenAI key here and LlamaIndex will pick it up when it's creating any of the models or embedding models. Also, this needs to be in your environment file as well. Now we can actually bring our data in. So we're going to be using the load dataset from Hugging Face datasets library, and we're going to be using the movies library. I've spoken about this dataset before, and this dataset basically contains 1,500 rows of movies and other attributes associated with the movies. And this can allow us to conduct a simple use case such as movie recommendations. And this dataset also comes with its own embedding um, plot embedding field as well, which means that this dataset has an embedding field that is based off the plot of each of the movie. But we're not going to be using this. We're going to be creating a new embedding field and we're going to be using the latest embedding model from OpenAI. This was created using the ADA 002, and we're going to be using the text-free embedding models. So next, this is just a bit of cleanup here. I'm going to be using the full plot to create the embedding field. So I'm going to drop any data row that doesn't have any full plot, just to make sure that the data is clean and there's no missing data. And we're also going to be removing this plot embedding column because we don't want to use that. So we move on here just to verify that everything is all good. And we can see we've removed all the fields we don't need. As you can see, we have that core LlamaIndex library, and we're also bringing in the other integrations that we need from OpenAI, which is the OpenAI model and the embedding model. And this part is actually a global configuration. So with the new library, you get access to the settings model, which allows you to scope at a global level the LLM you want to use for further downstream processes, and also the embedding model you want to use as well. So you don't have to redefine this, but you can also override this in later downstream processes if you want to change it. But this is quite cool because now you have that global scope and you don't have to keep defining it as well. But here we're using the text embedding free small embedding model with the dimension of 256. We're just going to run this and this should set all the global configuration for LlamaIndex. Once we've got all the global configuration set, the next step is to convert each of the documents we have. So from our data set, we're converting each of this data row into LlamaIndex first class citizen data structure known as documents. Documents are a data structure that LlamaIndex recognize, and each document you can essentially think about it as a data row. That each document that we're going to create corresponds to a data row here. So what we need to do is manually create this document that we import from the LlamaIndex core library. So we're just going to import this document constructor and we're going to manually create the documents ourselves. And here we can see I'm converting these fields, these attributes from the initial documents that we have in our data set. I'm converting them into JSON strings because some of these fields were actually a list containing strings or other data types. But LlamaIndex actually needs data, the metadata within a document to be either string, int, float, or none. We can't pass in an array type object. So we convert this into JSON strings. And I select specific attributes that I want as well. So here is where we're actually creating the document. I've just named it Llama document. And for a single document, I am just going to get the text field, which is going to be the full plots like I mentioned earlier. And what happens is further down in downstream processes, when we're creating the embedding for this document, LlamaIndex uses the text field to create this embedding. And next we have the metadata field, which we're just gonna pass it the entire document that we've changed the attributes of up here. So we're just gonna pass it the entire document. But one thing I'm going to do is use the other extra attributes that allow us to limit the amount of attributes, the amount of fields that the LLM can see when we're actually trying to get a response from an LLM. So we can exclude the full plot. And I'm doing this because we already have the full plot in the text that will get sent to the LLM anyway. And I'm also ignoring Metacritic, which most of this is not relevant to providing an appropriate response. Also, I'm excluding certain attributes when I'm creating that embedding. So I'm excluding the full plot again because it's included in the text field already. And I'm excluding a bunch of other attributes that are irrelevant for me creating an embedding. So I don't want the embedding model to use this data to create that semantic context of the embedding. I don't need that. And the rest of the attribute are just how the metadata is displayed when it's passed into either the embedding model or the LLM. So we're going to put each of this document into this container, this list I've called Llama documents. And this is going to be the new data structure we're moving with. We're going to be taking moving forward. But let's see what we can actually pass into the LLM and the embedding model whenever we pass an input into these models. So we can see the LLM actually gets the metadata. It gets the director that we've specified and the cast of the countries, the type of the movies. But as you can see, it also gets the content as well, which is this primary full plot. And the embedding model actually sees a bit less of the attributes because I want specific data points to contribute to that embedding model and not all of it. And again, it still gets content. So we can see what a document actually looks like, just one single document in that document list that we created. And we can see the document as an ID that has been given by LlamaIndex, and the metadata is within the documents, right? Is within the documents right inside of the metadata attribute corresponding to the document. Now we can move forward and actually create the embeddings for each of this document. So we're going to use the parser, the sentence splitter, and we're going to create nodes. Nodes are another first-class citizen data structure within LlamaIndex. And essentially, nodes are probably the simplest data structure you can have in LlamaIndex. And what we can do is each node we can actually get and assign an embedding. And these nodes are what are actually going to get put into the vector database. So here we can see we're only going to be using that globally defined embedding model. They can just call it and just use it to get the embedding. This actual process might take a while because we're embedding about 1,400 plus nodes. So it might take a while, but it will get done right within under five minutes or so. So the next step here is quite crucial because this is where we're going to create our MongoDB database collection and also our vector index. And I'm going to quickly go through the steps, but I've also pasted some guides here that will enable you to follow some instructions to get all the relevant resources created and also get your connection string that we're going to be using. But I could quickly show you the process. And here is my MongoDB Atlas. And whenever you get into MongoDB, you go into this dashboard page where you can create your cluster. So MongoDB offers this free shared cluster. So you can just click on that and just click a provider, select a provider, and select your region. Select a region the closest to you. And that's pretty much everything you have to set. If you want more storage, you can upgrade to using a better machine if you're going to be storing loads of data. But if you're just for experimentation purposes, this should be sufficient. Then we don't need to conduct any other additional settings. But one thing I do like to do is I do like to set like an environment key and just put like a development, just so I can know which cluster I'm using for development and the ones I'm using for production. But I've already created a cluster. We're going to go into the cluster right now. To access your cluster, you can just go back to the database page and then you'll be able to see all your clusters here, and you can just browse a collection. And if you want to create a database, which is what you'll be doing if you're following the instructions here, you'll click on create a database button. And we're going to be creating a database called movies, and the collection will be called records, movies records, which I've already created. But you just create that and that should create the new database and collection for you. After you've created your database and your collection, you need to create your vector index. And this is important. And the way you do that is just using the visual editor. Using the visual editor, you can just create your vector search index by using the JSON editor right here, and then click next. And this is important. The naming of your index is important because we're going to be using this name and referencing it in LlamaIndex. We're going to be selecting the movies database, and we're going to be selecting the movie records for you to modify or change the vector search index definition. So right here, you can just select right here, we have the vector type, which is vector, and the path. This path is going to be the path to your embedding. So it's going to be called, we're calling it embedding for each document. What is the vector embedding going to be called? The field, and it's going to be called embedding. The dimension, we're using the small version of OpenAI with the 256 dimensions. So our one is going to be 256. Then we have the similarity function. So this is the function it's going to be using to calculate the distance between the query embedding and the embedding within the vector space. But one thing about MongoDB is you can hover on any of this attributes and it gives you like a definition and also more resources to understand what are needed to be placed within the value of the field. So now that when you're done with this, you just click next, because I've already done all of this process already. Your vector search index will be active once it's ready to be used. And when all of the steps are done and completed, you can go back into your code, and we are going to then use PyMongo to create a Mongo client that gives us access to our cluster, database, and collection. And that allows us to manipulate the database and the records within the collection as well. So that's what this entire cell does. And the key thing is to obtain the connection string for your cluster and place that in your environment variable. I'm using the Google Colab secrets. And then I'm just specifying the connection string to the secret to Mongo URI, and that gives me access to it. Right here, I'm doing a bit of cleanup because I just want to work with a clean set of collections. So I'm deleting any record within the collection. So this is just to make sure that there is no existing records. And I did this previously. I've run this several times. So I deleted 1,452 records. This next step is where we make a connection from the scope of LlamaIndex to the vector store to MongoDB database that we're using. So here we have a variable called vector store that we're assigning to that MongoDB Atlas vector search instance that takes in that PyMongo Mongo client, which represents a connection to our cluster and database. And we specify the database name and the collection name, and also very importantly, the index name as well that we specified when we're creating that vector search index in MongoDB Atlas. Then we could conduct the data ingestion process of a RAG pipeline by just calling vector store dot add and then passing in the nodes that we created earlier. And these nodes contain all the embeddings that we have. So, and that this process is relatively quick. Next, we're going to create an index from our vector store that allows us to do an efficient vector search query on all of the content of the index. So very simple, one line, and we achieve this, which gives us the ability to use the LlamaIndex allows us to use the index as a query engine. And here I'm just specifying to only use the top 3 similar documents as context, additional context to the user query. And here I'm just asking for a romantic movie that is suitable for Christmas. So, and this is what the suggestion was OpenAI model gave when asked to query this query and provided with the additional context of these essential records. So here we can see what's being used as additional context, and these were the top 3. And really, that's how you can build a RAG system, a RAG pipeline, using the new LlamaIndex library, the updated library from 0.9 to 0.10. It's relatively straightforward. The most massive change, the biggest change is really how you get your libraries and where the modules are located. We have this core library and other items or components of your RAG pipeline, like the vector store, are located in other libraries as well, which you have to install separately. But for bonus, we can actually look at something here, which is more of a specific use case. I'll touch on this in another video in the future, but you can do specific metadata filtering, which means you use the metadata attributes to reduce the amount of records you want to conduct the vector search on. Use LlamaIndex makes this very simple. So in a future video, I'll be talking about filters. And in this filter, we're using this exact, we're only going to consider metadatas that have this exact doc ID to use as the information we pass into this query. And there's only one record, so it uses that exact record that we need because we're doing an exact match filter. So I'll talk more about this in future videos. I'm also talk about the LlamaIndex ingestion pipeline or the query pipeline. There's a lot of use cases and a lot of nuances we can speak about. So remember, all of this is all in article form in this article, so you can read it, or you can just jump into this repository and download this file and experiment with it yourself. As usual, thanks for watching. And if you like this video, give it a like and subscribe, I guess. You could comment below what you want me to touch on. Are there any libraries you want me to look into? Are there any other AI engineer ideas and concept that I should explore? Should we talk about agents? That's an interesting concept. But tell me what you think about the definition of this AI stack. This is the POM stack. Python, OpenAI, LlamaIndex, or the L could be LangChain as well, and the M for MongoDB. I'll be experimenting with other stacks as well, seeing how they compare to other stacks and seeing which one are very easy to use together. So thank you for watching the video, and yeah, happy hacking.